Blue Origin is landing on the moon this year. At least that's what the Jeff Bezos-owned rocket maker has been claiming at a recent meeting of the Lunar Surface Innovation Consortium. A Blue Origin senior vice president revealed that the company has 2 prototypes of its Blue Moon lander currently in development. The first is under construction right now at a dedicated facility in Florida and is scheduled to be complete in the coming weeks. Following that, the Mark 1 prototype will be shipped out to NASA's Kennedy Space Center and integrated into a Blue Origin New Glenn rocket for launch before the end of this year. New Glenn has flown once in January 2025, and the heavy-lift rocket was able to successfully deploy a test payload into its target orbit. The New Glenn booster also attempted a water landing on that flight, but it failed on re-entry. Blue Origin is currently scheduled to try again with a New Glenn launch targeting August 15 for flight test number 2. If New Glenn is successful at deploying Blue Moon into Earth orbit, the lander will then fire up its BE-7 hydrogen engine to make a 7-day journey to the lunar surface. Blue Origin is targeting a location on the Moon's south pole, and they're aiming to land with an accuracy of less than 10 m away from the intended target. Once on the surface, Blue Moon will deploy payloads from both private customers and NASA. All that we know right now is that the NASA payload will be on board to measure the dust that gets kicked up by the engine's landing burn. This would be the biggest and most powerful vehicle that's ever landed on the Moon, even bigger than the Apollo spacecraft. So, we're very curious to see what effect it's going to have on the lunar environment. It's important to note that there are 2 variants of the Blue Moon. Mark 1 is designed to work as an uncrewed robotic platform with a payload capacity of around 3 metric tons to the lunar surface. This is what the company's testing right now, but these tests will pave the way for Blue Moon Mark 2. That's the much larger human landing system vehicle that NASA has contracted to deliver astronauts to the Moon on Artemis 5, if such a mission actually goes through. A lot of this schedule is totally up in the air right now, but that's not stopping these companies from pressing forward with their hardware designs. Before Blue Origin can land people on the Moon, they need to verify yet another spacecraft. That's the CAS Lunar Transporter, which is a refueling tug designed to support Blue Moon Mark I. Because the human-rated lander will be bigger, will carry more payload, and will need to lift off from the Moon to return its crew back home. That's going to require a refueling session before making the final descent to the surface. So, the transporter is going to launch on a separate New Glenn rocket and deploy into Earth orbit. Then, the transporter is going to be fueled with excess propellant from the New Glenn upper stage before setting course for lunar orbit. The transporter can carry 100 tons of fuel from the Earth to the Moon or even 30 tons of fuel to orbit around Mars. The transporter will park in the same near-rectilinear halo orbit around the Moon that NASA is planning to use for crew transfer from the Orion spacecraft. Once there, it's going to meet up with a waiting Blue Moon Mark and transfer propellant into the lander. Now, let's be clear, this is no small task. A cryogenic propellant transfer in space between 2 vehicles has never been done before. SpaceX has been planning to attempt the first orbital propellant transfer this year, but their Starship keeps blowing up, so it might be some time before we see that happen. Blue Origin says they are actively working on technology to hold that cryogenic liquid hydrogen at extraordinarily low temperatures for long periods of time. At a test facility in Washington state, they've been able to hold fuel with zero boil-off at temperatures as low as -424 degrees Fahrenheit. Either way, that's all stuff that won't be relevant until several years into the future. What's important right now is that Blue is nearing completion of their first Mark 1 lander as we speak. They are currently integrating the main engine and expect that work to be done by the end of the summer, and a second Mark 1 lander is not far behind. Within 6 to 8 months of the first launch, Blue Origin will be ready to try again. So if the first moon landing fails, the company has an opportunity to iterate and test their corrections. If the first landing succeeds, then the company rides that momentum into establishing a solid presence on the Moon in 2026. And if that all works out the way that we just imagined it would, then that would put Blue Origin well ahead of their partners in the Artemis program, including NASA, who is supposed to be leading the charge back to the Moon by supplying crew transportation, but has instead just been struggling to keep up. Now, there are many reasons for this. Politics, leadership, money, but even core fundamentals like engineering and design have been faltering lately. Case in point, this recent engine test for NASA's Moon rocket that literally came apart at the seams. The giant solid rocket booster was tested in the desert of northern Utah, where Northrop Grumman has built and tested this type of rocket since the 1950s. These large side boosters were originally developed for the space shuttle and have now been adapted to power the Space Launch System, which in theory will send people back to the Moon this decade. Motors of this type use a mix of aluminum powder, ammonium perchlorate as an oxidizer, and as a binder, which creates a rubbery paste similar in consistency to an eraser. The paste is packed into the shell of the booster with a hole going straight down the middle. The fuel burns from the top down and exhaust travels through this tunnel to the engine nozzle at the bottom. All of the side boosters that are set up for use in the near-term Artemis missions like Flight 2, 3, and 4 are literally just recycled hardware from the Space Shuttle program. But for long-term Artemis missions, bigger and more powerful boosters will be required to lift an upgraded SLS and Orion spacecraft combo. So, what NASA has done is made some design tweaks to the already decades-old solid rocket motor. This project is known as the Booster Obsolescence and Life Extension. The new booster isn't just longer, but also is made of a lighter carbon fiber composite casing as opposed to the old steel casing. A Pathfinder version of these boosters was built at Northrop Grumman's facility in Promontory, Utah, and was tested at their static fire stand. The stand is specifically designed to test these solid rockets, and instead of firing straight down, it allows them to fire horizontally by laying the rocket on its side. During this specific test, which happened to be the first test for this type of booster, onlookers could see the plume of exhaust, which appeared as a white cloud of smoke rising up into the air across the Salt Lake Valley. The test was just over 2 minutes and seemed flawless up until about the 100-second mark. At this point, the director of the test had just called out deluge activation to cool the pad, as we could hear from the in-stream audio. That was meant to prevent the pad from overheating by spraying it with water and dissipating the heat. However, no amount of water would prepare the booster for what was about to go down. Suddenly, exhaust began to seep out from the side of the nozzle. The nozzle's job is to convert slow-moving high-pressure exhaust into high-speed low-pressure exhaust by expanding the plume outward rapidly. This allows the booster to produce more thrust as more material is pushing against it. After this, the entire nozzle erupted, shooting debris along with smoke around the pad. One of the operators in charge of making the test callouts was heard saying, "Whoa," before letting out a soft sigh. They knew something had gone wrong and that this test had failed, but they didn't mention any details on the stream. Small grass fires began around the test stand caused by the anomaly. Obviously, the business end of the rocket is an important aspect, but a failure at the nozzle won't necessarily cause the entire motor to blow. This is why even after the unscheduled disassembly, the booster continued to operate for the rest of the duration. Because this uses solid propellant, there is no way to shut down the rocket once it has been lit. It will burn until it's out of fuel. After the test, Vice President of Propulsion Systems at Northrop, Jim Calbra, stated, "As a new design and the largest segmented solid rocket booster ever built, this test provides us with valuable data to iterate our design for future developments." Beyond this, not much explanation was provided, so we have been left to guess. And upon close examination of official and unofficial footage, we have a pretty good theory. It appears the hot gas first began to escape the booster between the nozzle and the skirt of the engine. The skirt is the flared-out part right above the nozzle that houses critical components to steer the motor. Likely due to a faulty nozzle or improper attachment methods, a hole was created at the top of the nozzle, which opened after a 100 seconds of fiery exposure. As the hole opened due to the extreme pressure from hot gas trying to escape, the components holding the nozzle together gave out, resulting in the first explosion we witnessed. Now that the nozzle was gone, the exhaust was no longer being expanded and instead exited the engine through the tiny neck before the nozzle. This also gave out a few seconds later in another smaller explosion, as some angles were able to capture. One result of the explosions was a shockwave that traveled up the hill. This means that if a failure like that took place during an actual flight of SLS, then the launch would almost definitely fail, even if the booster remains intact, and would probably have triggered an abort on the Orion crew capsule, bringing the astronauts back down to Earth and making for a very short yet spectacularly expensive trip. It's important to note that the hardware we just saw disassemble itself is supposed to fly an SLS Block 2 on the Artemis 9 moon landing. So, it's not entirely clear just how much any of this really matters because the only US official left in support of a long-term plan for SLS and Artemis is Texas Senator Ted Cruz. Everyone else has already come to the conclusion that at best, SLS can be useful to achieve an Artemis 3 human landing on the moon as soon as possible, hopefully before the Chinese, and then everything that comes after that is going to require a bold new direction at NASA. Whatever that may be, stay tuned.